Alright, this video is for the lesson 4.2 homework. We're going to do log functions today. Sorry, it's being weird. Alright, so what's number one?
The equation y equals log bx is equal to the exponential form blank x is greater than 0, b is greater than 0, and b does not equal 1.
So is it...
b to the power of y equals x.
That's right, okay. So b to the power of y equals x. So the base is always your base. So here it's the base of the log, here it's the base of the exponent. Is that all that one was asking?
Yeah.
Okay, 2.
The function f of x equals log bx is the blank function with base blank. However you say that L word.
Logarithmic?
Function with base b.
Okay. So that's a logarithmic function with base. I'll just put b like that. Okay. 3.
Log b is equal to what? Well, there's another b. Like a big b.
Log b,
Base size is log.
like this.
But
Oh, it's
Lowercase.
lowercase.
Oh, okay. Okay. Like this
yes. Equals it's 1.
equals 1, right? If the base is the same as this, equals 1.
Yeah.
Okay. 4.
Log b1 equals
So log of base b of 1,
it's 0.
huh?
0.
Is 0. Kind of like your exponent rules. Okay. 5.
Log b
Base of b
bx.
of x.
Like this.
No,
Oh.
there's a b. A lowercase b in front of the x. That's the same size.
Like that.
Yeah.
And
Equals,
to the power of it.
No. That's not right.
Where
So
And it's
log
b and then power
base
of
b
x.
of b of x. Right? That's how you'd say it.
log of base b of b, yeah,
Of x.
to the x
Equals x.
equals x. Okay. Cooking pretty good on this one.
The next ones are all, that's when the number, they start with the
Okay.
minus 3 equals log 7 of 343.
Wait. Log of base 7,
7 of 343.
like this.
Yeah.
Does it want it rewritten as an exponent?
What is the equivalent exponential form of the equation?
Okay. This stays your base. This becomes your exponent. This is what it's equal to. So if you check that with a calculator, like 7 to the 3rd, you get 343. Okay. Seven.
Okay. 2 equals log base of 4 and then capital M. I have no idea what.
Like this? Okay. Base stays your base. This becomes your exponent. Equals m. Does it want what m equals?
What is the equivalent exponential form of the equation?
This is the exponential form.
Yeah, so I guess they call it that.
You convert between the forms so you can solve, because now we can solve. We can go, oh, 4 squared, m would be 16.
It was just asking for that.
Yeah, I just want to show you that's why we convert between the forms, because we're going to get into these where we have to solve them. And you've got to be able to move between those forms pretty easily. All right, 8.
3 equals log
like that.
64.
Same thing. So b stays your base, 3 becomes your exponent, equals 64. So again, it's asking what number cubed would give you a 64. I think it's 4. Yep. Okay. 9. Yeah. Anybody else want me to do one of theirs?
Log, I'm just base of 3.
Wait, say it again.
Log base of 3.
Okay.
9 equals y.
9 equals y, and it just wants it converted again? Okay.
Exponential form.
So 3 to the y equals 9. And again, looking at it in that form, your little brains go, oh yeah, y is 2. Looking at it this form, you're just not used to that form, so it's hard for you to decide what your answer is. Okay. 10.
It's got 26 questions, but like a lot of this just.
Hopefully it's just stuff like this.
10's the reverse.
Almost all of it.
Huh?
10's the reverse. You have to make a log function.
Yeah, mine's.
Okay, so give me an exponential then, and we'll go the other way.
7 to the power 4 equals 2,401.
2,401, like that?
Yeah.
2401. Okay. So, exponent's what it's equal to. Base stays your base. And then 2401. Really what happens is, like, the exponent and what it's equal to kind of switch places. That's always how I've had kids try to explain it to them that way. Those switch places, and then the base always stays the base, if you think of it vocabulary terms. Ooh, y'all don't have to do near as much with these as we did last year, so that's good. Okay. 11.
1/4 equals 2 to the power of negative 2.
2 to the power of negative 2.
Yes.
And it wants a log.
Yes. In the library.
Okay, so negative 2 equals log of base 2. And then this would be a 4th. For some reason that doesn't seem right though. Because I don't think we can get a negative. Yeah, we can. Again, negative exponents. Huh?
I'll try it.
Well, so again, negative exponents. 2 to the negative 2. We don't ever write negative exponents. Kind of talked about this a little bit yesterday. Instead, we would write 1 over 2 squared, which is a 4th.
So the negative 2 equals what? That was correct.
That's how I would convert it. But something in my brain's clicking like, there are certain situations that can't happen. But I mean, that one I think is okay.
Yep.
Yeah?
Just in the log. Got it.
Okay. 12. Mm.
12 to the power of 5 equals x.
Okay. So log base 12 of x equals 5. And that throws me off too, because typically we put that in parentheses. So if you see me do that, I'm just used to putting that value in parentheses.
So do you put it in parentheses?
You haven't had to so far. Like I said, if you see me do that, that's habit for writing it out.
So just put x, no parentheses?
You should be able to just do,
No parentheses.
you should be able to do it like this. Typically when you write it, you put it in parentheses because other things can happen. And I don't know if we're going to do transformations on these, but if we do, I can show you why my brain does that. I don't want to give you too much information. All right, 13. Okay.
Equals 147.
147. So, log of base 7 of 147 equals x. Yeah, holy cow, this is way easier than what my kids had to do last year. I mean, we're going to get into some tougher stuff because I've seen it on there, but this is nothing compared to...
Replacing my y, yeah, no, that still makes.
We're flying through this.
Yeah.
Oh, now we're solving.
Now we're solving.
Yeah, so it gives you like the function, so like minus log base of 2 of 16 equals, and it wants you to find the
Okay.
exact value.
I'm pulling these notes right now, so in case we need them or if I need to make copies and stuff for you guys. Okay, so tell me what your 14 is, Shelby.
Log with a base of 2 of 16 equals. And it just
Oh, just wants to know what it
find
equals?
the exact value of the function without using the calculator.
Okay. So if we rewrite it as an exponent, right? 2 to the x equals 16. We have to know what power 2 is raised to make it a 16. Okay? So 2 squared is 4. 2 cubed is 8. All you do, 4 times 2 gives you 8. 2 to the 4th, 8 times 2 is 16. So your exponent, x here, equals 4. That's how I would solve it. I'm looking through this right now to see. X equals 4, yeah.
Yeah, it just has us finishing out the equation.
And usually it's typically just rearranging. They can get a little bit more difficult, but usually it's just rearranging. All right, 15.
Someone else want to do that?
Yeah. Somebody else, give me your 15.
Alright, log to the base of 2 of 16.
I just did that one.
Yeah.
Mine was 8 instead of 16.
Wait, log base 2, 8?
Yeah, it's just 30.
Yep, so we already did it. X equals 3. Glad she put easy ones. They're not.
Oh, I have a fractional one now.
Okay.
Log with a base of 3 of 1/3.
Okay, log base 3 of a third equals something, right?
It's blank.
Yeah. Okay, so 3 to the x equals a third. Okay, so here's where those exponent rules come into play. Automatically, I know that has to be a negative exponent because it's becoming a fraction. Since the 3 didn't change, I know that it's 3 to the negative 1. Those are just exponent rules. 3 to the negative 1 is the same as 1 over 3 to the first. And so x here is just negative 1.
Question 18, I've got a square root.
Okay, I'll show you how to do that too. Yeah, because it's exponent rules too. What about 17?
Okay. Log with
Oh,
base
that's
of
just
7 of 1 over 49.
Okay, same setup here. So 7 to what power would give me 1 over 49? So again, since these are different, what I could do 1 over 7 to the x equals 1 over 49, which means the denominators have to be the same. 7 to the x equals 49. Well, 7 squared equals 49.
So it would be
X is 2. Negative 2. Shh, negative 2.
That's what I thought it was, but I didn't.
It's positive 2 if it's down here. As soon as we write it like this, it's negative 2. All right, Peyton, give me your square root one.
Oh, I already solved it.
Oh,
Anyways, log with the base of 7 in parentheses square root of 7.
like this? Okay, just so y'all know, a square root
Is a fraction.
is like 7 to the 1/2. Okay, so a square root is raising it to the power of a half. Raising it to the power of a third is a cube root. Because used to, we weren't able to cube root in the calculator, but you could raise it to a third. You could raise it to any power. And so this one would be 7 to the x equals square root of 7, or 7 to the x equals 7 to the half. If the bases are the same, then the exponents, you can set the exponents equal to each other. In this one, there's nothing to solve. X just equals a half. They get more complicated just to kind of show you. So like here, you kind of really have to know what you're looking at. Oh, 25 is a base 5. It's 5 squared. And so you have to convert it where your base is the same, and then you can set the exponents equal to each other. So they progress to this extent. You have to know your log rules. There's a whole list of rules that go with these things. Like exponent rules. There's a whole list of rules for logs. All right, 19.
Log with the base of 4 of 2.
Okay, so 4 to the x equals 2.
The square root.
Is it a half?
Yes.
Yeah. So it would be x would equal a half there too.
If it's smaller without turning it to a fraction,
Mhm.
it has
Mhm.
to be a fraction.
My brain was trying to think of a way to show the work for it though.
I don't know. It's half of the base.
It's half, I mean, yeah. But your brain tells you that, not
Start
here.
square
I just
root.
because I'm curious now, I want to know how to show the work to that. So come on, load for me.
So you just find like square root, cube root, keep on going down the line.
Let's just see. Oh, so that's what they did. They based it. Okay.
Cool.
Exponent rules again. I can make this a base 2. I can make 4 into 2 squared, right? And then this is exponent rules. Power to a power, you just multiply them together. Okay, and again, a 2 is just a 2 to the 1. If the bases are the same, then you can set the exponents equal to each other. Divide both sides by 2, and you get x equals a half. So yeah, that's exponent rules. I don't know how deep she's going to want you to show your work, but if you have one that's not a straight up like, oh yeah, that's the square root, that's how you show your work on that, is you break it down into the bases. Try to write them where they have a common base. And then use exponent log rules from there.
20 and 21 are easy.
Okay. So you want to skip those? Okay.
Oh wait, that's how you did it.
Everybody got 20 and 21, or does anybody need help with those two?
Well, it's gonna get help on 21, but
21?
I just remembered what.
That's just exponent rule.
Yeah,
Okay.
It's 0.
Oh, the 0 rule?
Yeah.
Okay.
Mine was log base 8 1.
So log base 8
Of 1.
of 1 equals x,
Yeah.
which would be 8 to the x equals 1. Anything raised to the 0 power equals 1.
Yeah.
0 rule.
It would have helped me if I didn't have log base of 2 to 1. So I'm like, how do you?
Oh.
Have it?
I gotcha, yeah. And again, it's rewriting it, and your brain has to click and go, oh, yeah, exponent rules that I saw 4 years ago and never saw again.
I only saw them last year.
Should have seen them freshman year.
Yeah, mine was freshman year.
Yeah. All right, 22.
Log with the base of 4
Okay.
of 4
Okay.
to the 6th power.
The 4 is raised to the 6th power. Okay.
So we have to solve for.
Okay, so we would have 4 to the x equals 4 to the 6th, right? If the bases are the same,
So
I can set the exponents equal to each other. Again, where that gets tricky is when these aren't the same here. Like this 4 and this 4 aren't the same value, and you have to figure out what common base they have. That's when things get tricky.
Is that a point where you would? Like,
I would
solve
I
for
would
the 4?
factor. I would start factoring stuff to find a common base. Hopefully there'll be one that we can look at that's that way.
Find the domain of the function.
Okay?
G of x equals log to the base of 3
Okay?
to, in parentheses, x minus 6.
Like this?
Yes.
And it wants the domain?
Yes.
Okay. Show you what a logarithmic function looks like here. So your standard log, oh, I can't remember how to do these.
would it be all positive numbers?
Domain is not. I can't remember how to do a log in these. Okay, give me a second. All right, so on Desmos, that little keyboard that you have down there, if you go to functions, there should be, the log function should be in there. There it is. Okay. So, log of base, let me do just a standard one. 10 of x. There's your base function, right? Parent function of a logarithmic function. This one would be, the parent function would be a base 3, right? Okay, so there's the parent function. So what happens, all it is, it's the inverse of an exponential. So remember with an exponential, we have that asymptote at y equals 0. These we have an asymptote at x equals 0 because it's an inverse. Inverse reflects over the y equals x line. So if we do x minus 6, you can see that red line, it shifts. So now my asymptote here is x equals, should be x equals 6. And it'll never cross that line. Here's why it has a domain. So the domain on this one would be from 6 to infinity. If I plug a 6 into this, right? Log of base 3, 6 minus 6. I can't take the log of a 0. Is that right? Let me do it on this side.
How did you get the base in the
That keyboard,
Yeah.
that keyboard automatically puts it in there. And our calculators will do it too.
It's not doing that for me.
On Desmos?
Yeah.
Okay, on Desmos. Hit the keyboard. Go to functions. Go down to calculus. And the log A, not just the log.
Oh, log A.
Yeah.
Okay, all right.
Log is base 10. That's kind of the parent function standard form. I can't even think of the name of it now. Anyways, but yeah, log A will give you where you can put the little subscript in there. Anyways, you can't do any number that's less than 0. Yeah, less than or equal to 0. So that's why the domain is from 6 to infinity, because you can't plug any number in here that would make this value be negative, 0 or negative. So again, how to show your work? X minus 6 has to be greater than or equal to, actually, x minus 6 has to be greater than 0. Add 6 to both sides. X has to be greater than 6. And then that's the interval notation for that.
Log. Wait, there's no base. It just has a 10.
Okay, so like, and then just something in parentheses here.
No, it's just 10 to the power of 6. Like right next to log, it's 10 to the power of 6.
10 to the power of 6 like this.
Yeah, just no parentheses.
Okay, this is base 10. Okay, this is what I was talking about with the other one. It wants the domain again of this.
No, it just wants to solve it.
Oh, it wants you to solve it. If they don't put a little number here, if they don't put a base here, it's an assumed 10. Okay? And so that's what you were looking at, Peyton. That one key that you saw that was just the log. That's the assumed base 10. If the base is 10, and that used to be, again, all our calculators would do was base 10. We've come a long way, even in 15 years, where we can do more than that now. Okay, so this one would be 10 to the x equals 10 to the 6, so x equals 6.
Now we're in inverse, I think is what it is.
Inverses? Okay.
It says in with a base of e to the power.
Oh, no, you're saying ln.
Oh, sure. I don't know. It was
ln what?
with the base of e, I think. It just has an e.
Like this?
Yeah.
Okay.
To the power of 4.
To the power of like this? Okay. That's the natural log. Okay. So the e is Euler's number.
Oh, is that the 2.8?
Yeah, let me get to. Where are my notes on the natural log? Okay, so how we would write that?
Oh, it's like 9 decimals, but it's approximately 2.72.
But we don't have to worry about the approximation or anything like that. Sorry, I'm trying to find my rules so you know what it is.
Like the exact number.
What is it wanting on this one?
Just wants to solve it.
Okay, so let's look at this one then. Okay, so ln and then e to the 4th. Ooh, it doesn't like that one. Okay. See, and there's a whole bunch of rules in that. Okay. Why? I can't find my page that has all those
So
rules.
it says in the e to the power of, so this is the example, but it says ln e to the power of 12 is the natural blank, however you say that word.
Natural log.
Of e to the power of 12. By definition, this could be written as log e to the power of 12.
Okay.
E, base E, or so
Log
base E and then a regular E.
of base E and then an E to the fourth.
Yep.
Is that how it's got it? Yeah. There's another rule with that too, and I can't. My brain won't go there. We don't do exponents typically in logarithms. Exponents become coefficients. And so technically we would write this as 4 of the natural log of E. Well, the natural log of E equals 1. Okay? So really, this right here is equal to 4 because this right here is equal to 1. But we're missing a whole bunch of rules. In the notes and stuff like that, does it have all the rules?
On the view example, it says after like that, it says the third property of log states that log base b to the power of x equals x. Therefore,
But in the notes and everything that she gave you, it doesn't give you like the rules for that. Again, there's all these properties.
it just says for b is greater than 0 and b does not equal 1. So log with base b to the power of x equals x.
Yeah.
That's all.
I will try to find something that'll give you like all the rules. Like I said, all of these rules, just kind of being able to have a chart and go, oh, if this is raised to a power, I can make that power a coefficient, and knowing those rules makes it where you can show your work on these. That's what I'm worried about, is being able to show our work. All right, last one, 26.
E to the power of the L and
Like this?
yeah, and 136. It's up there then, like to the power of.
Like this?
Yeah.
Yes.
And we want to know what that equals. So log of E to the x would equal ln of 136. Well, log E of x equals the natural log of x. And so x would equal 136. Right?
Okay, so how do we get ln?
Okay, so we don't do log of base E. Log of base E, instead we write the natural log. That's the natural log. So that's the first rule that you have to know. Log of base E is equal to natural log. So if I wrote log of base E of 12, instead I would write natural log of 12. We just don't write logarithmic of base E. Does that make sense? Yeah, those are
So-
tough without all
so
the
that-
properties.
You just put in, I guess, an extra equal sign
I put an X here. If we're figuring out what this is,
to the side when you're doing log.
where?
Farther down the. So okay, in that middle one you have a natural log x equals log equals 136.
Oh, that shouldn't be an equals there. That should just be natural log of 136. Ooh.